When engineers at Hägglunds and Bofors were told to design a new infantry fighting vehicle in the mid-1980s, they made a decision that bordered on absolute madness. They took a massive 40mm anti-aircraft gun, a weapon originally designed to swat heavily armored bombers out of the sky during the Second World War, turned it horizontally, and shoved it inside a relatively small two-man armored turret. The resulting recoil forces were so violently destructive that they threatened to tear the turret ring right off the chassis. This was not a weapon meant for a ground vehicle, but the Swedes simply did not care. They needed a vehicle that could crack open Soviet BMP troop carriers like tin cans at ranges exceeding 2,000 meters, and they needed to do it while plunging through waist-deep Arctic snow. This singular, ruthless design choice birthed the Combat Vehicle 90, universally known as the CV90. Today, it is widely considered the most lethal, heavily protected, and tactically flexible infantry fighting vehicle on the European continent. It has outlasted its original Cold War rivals, evolving from a lightweight snow crawler into a heavily armored 38-ton brawler. But that raw power came with a hidden cost the engineers had not fully anticipated. The true story of the CV90 is a brutal lesson in the laws of physics, the uncompromising nature of modular engineering, and the heavy physical toll placed on the crews who actually have to fight inside it. Before we tear apart the armor packages and dive deep into the absolute chaos of loading that Bofors cannon under fire, I want to welcome you to the channel. If you are obsessed with the gritty, unpolished reality of military hardware, make sure you hit subscribe and join the community. We do not just read specification sheets here. We look at how these machines actually operate in the mud, in the snow, and under the crosshairs of enemy optics. Let us get back to the Swedish engineering. The origins of the CV90 are deeply rooted in the strategic paranoia of the late 20th century. During the Cold War, Sweden maintained a policy of armed neutrality. They were not part of NATO, meaning if the Soviet Union decided to roll across the northern borders, the Swedish military would be fighting entirely alone. The primary theater of this hypothetical war would be Norrland, the vast, unforgiving northern region of Sweden, characterized by dense pine forests, treacherous bogs, and snowdrifts that can swallow an entire truck. Standard main battle tanks, like the British Centurion that Sweden operated at the time, were simply too heavy for this terrain. They would sink into the muskeg or get hopelessly bogged down in the deep powder. The Swedish army needed something lighter, faster, and infinitely more adaptable. They established a requirement for a family of armored vehicles built on a single unified chassis. The baseline variant had to carry a squad of heavily armed infantry, provide overwhelming fire support, and survive direct hits from enemy autocannons. Above all else, it required exceptionally low ground pressure. To achieve this, the designers at Hägglunds, a company that had built its reputation engineering specialized over-snow vehicles, started with the tracks and worked their way up. They gave the original CV90 a relatively wide track base and a carefully balanced suspension system. The hull was crafted from all-welded steel armor, sloped at aggressive angles to deflect incoming kinetic energy penetrators. In its original 1990s configuration, known as the CV9040, the vehicle weighed around 23 tons. This was deliberately light. It allowed the vehicle to glide over snow crusts that would trap an American M2 Bradley or a Soviet BMP-2. Powering this steel wedge was a Scania DSE-14 V8 diesel engine, producing exactly 550 horsepower. Scania was famous for building indestructible commercial truck engines, and putting a commercial off-the-shelf power plant inside a combat vehicle was a stroke of logistical brilliance. Spare parts were everywhere, and the mechanics already knew how to fix them. The engine was mounted in the front right of the hull, right next to the driver. This front-mounted engine layout provided a massive secondary benefit. If an anti-tank rocket penetrated the front armor plate, it had to blast through a solid block of iron, diesel fuel, and cooling jackets before it could reach the passenger compartment in the rear. The engine block literally served as sacrificial armor. But mobility and survivability were only half of the equation. The real defining feature of the original Swedish CV90 was its main armament. The military wanted a gun that could absolutely obliterate enemy light armor, shred attack helicopters, and annihilate entrenched infantry. Instead of developing a new, lightweight autocannon from scratch, they turned to Bofors. Bofors took their legendary 40mm L-70 anti-aircraft cannon, inverted it, modified the feed system, and crammed it into the turret. The results were devastatingly powerful on paper. The gun fires a massive projectile, weighing almost a kilogram at a muzzle velocity of 1,000 meters per second. When a 40mm armor-piercing, fin-stabilized, discarding Sabot round hits a target, it delivers nearly double the kinetic energy of the 25mm gun found on the American Bradley. It does not just puncture enemy armor, it completely caves it in, shattering internal components and neutralizing the crew instantly. But shoving an anti-aircraft gun into a tank turret created an absolute ergonomic nightmare for the gunner and the commander. The sheer physical size of the 40mm ammunition meant that a traditional belt-fed mechanism was impossible. The rounds were simply too heavy, and the links would snap under the stress. So, Bofors designed a mechanical carousel system located beneath the gun, divided into 3 separate vertical magazines. Each magazine held exactly 8 rounds. This gave the crew a total of 24 rounds ready to fire at any given moment. The commander could load one magazine with armor-piercing sabot rounds, another with high-explosive fragmentation rounds, and the third with general-purpose ammunition. With the flick of a mechanical switch, the feed mechanism would rotate, instantly swapping the ammunition type being fed into the breech. It was an incredibly flexible system for a chaotic battlefield. But here is the catch. 24 rounds disappear in a heartbeat when the gun fires at 300 rounds per minute. Once those magazines run dry, the vehicle is essentially defenseless against heavy threats. The process of reloading those magazines is entirely manual, heavily labor-intensive, and physically exhausting. The spare ammunition is stored in a carousel at the very bottom of the turret basket. To reload, the commander has to physically pull heavy clips of 40mm shells from the floor, heft them up into the cramped turret space, and forcefully slam them into the bottom of the feed magazines. Doing this while the vehicle is stationary on a firing range is difficult enough. Doing it while the driver is slamming the chassis over frozen ditches at 50 kilometers per hour in complete darkness, while artillery detonates outside the hull, that borders on the impossible. The commander essentially has to stop commanding the vehicle and become a manual laborer just to keep the gun fed. Furthermore, the spent brass casings from the massive 40mm rounds had to go somewhere. Because the breech of the gun sits so far back in the turret, the engineers could not route the empty shells out the front. Instead, they installed an ejection port directly in the roof of the turret. When the gun fires, the massive smoking brass casing is violently ejected upward, popping out of the roof like a morbid jack-in-the-box. It is a visually striking piece of engineering, but it means a hail of heavy, red-hot brass routinely rains down onto the rear deck of the vehicle. Any infantry dismounts standing too close to the hull during a firefight quickly learn to keep their heads down, lest they be knocked unconscious by their own vehicle's spent ammunition. Despite these severe ergonomic flaws, the sheer lethality of the weapon system kept it in service. This lethality was massively amplified by the introduction of 3P ammunition. 3P stands for pre-fragmented, programmable, proximity-fused ammunition. It is quite possibly the most terrifying anti-infantry round in existence. As a 3P round slides into the breech of the Bofors cannon, a digital setter magnetically programs a microchip inside the base of the shell. The gunner can tell the round exactly what to do. He can program it to detonate exactly 5 meters above an enemy trench line, showering the infantry below with thousands of tungsten fragments. He can program it to punch through a brick wall and detonate inside a building. He can even set it to proximity mode to swat low-flying drones and helicopters out of the air. When combined with the universal tank and anti-aircraft system known as the UTAAS sight, the gunner has an almost unfair advantage. The UTAAS sight features a third-generation thermal imager and a highly advanced laser rangefinder. The gunner simply puts the thermal crosshairs on the target, lasers the distance, and the ballistic computer automatically elevates the heavy gun barrel, calculates the lead, and programs the fuse. All the gunner has to do is pull the trigger. But the Swedish military was not the only organization paying attention to this platform. By the late 1990s, other European nations were looking to replace their aging fleets of M113 armored personnel carriers. They saw the Swedish CV90 gliding through the snow and recognized the brilliance of the chassis. However, foreign militaries took one look at the manually loaded upside-down anti-aircraft gun and politely declined. They loved the hull. They hated the gun. This rejection forced Hägglunds, which was eventually absorbed by BAE Systems, to radically pivot their design philosophy. They realized that to win export contracts, they had to decouple the chassis from the 40mm Bofors. This led to the creation of the CV90-30, the first major export variant specifically designed for Norway. Instead of the Bofors, the Norwegians demanded the American-made 30mm Bushmaster 2-chain gun. The Bushmaster was entirely different from the Bofors. It was externally powered by an electric motor, meaning it did not rely on the explosive gases of the fired round to cycle the action. If a round failed to fire, the electric motor simply rotated the dud out and cycled a fresh round into the breech. More importantly, the Bushmaster was dual-fed via continuous belts of ammunition. This completely eliminated the physical nightmare of the commander manually slamming clips into a carousel. The gun fed directly from 2 large ammunition boxes located inside the turret, holding a combined total of 160 ready rounds. The switch to the Bushmaster completely changed the operational rhythm of the vehicle. It traded the raw, brute force kinetic energy of the 40mm shell for sustained, reliable, high-volume fire. This export pivot saved the entire CV90 program from becoming an obscure, single-nation oddity. After Norway bought the 30mm version, Switzerland and Finland quickly followed suit. Later, the Netherlands and Denmark pushed the firepower envelope even further, ordering the CV90-35, armed with a 35mm Bushmaster 3-chain gun. This larger weapon split the difference perfectly, offering more explosive mass than the 30mm, but maintaining the reliable belt-fed mechanics that the 40mm lacked. But as the firepower evolved, a massive silent problem began to plague the chassis: armor weight. When the original CV90 rolled off the assembly line, it weighed 23 tons. It was designed to stop 14.5mm heavy machine gun fire from the front and shrapnel from the sides. But as the vehicle entered the 21st century, the threat landscape drastically changed. The rise of advanced anti-tank guided missiles, tandem-charge rocket-propelled grenades, and heavy improvised explosive devices meant that bare steel was no longer enough. European armies started bolting massive modular armor packages onto the base hull. They added layers of MEXAS and AMAP composite ceramics, which shattered incoming kinetic penetrators. They bolted heavy steel plates to the underbelly to deflect mine blasts. They strapped on the famous Barracuda mobile camouflage system, a specialized netting that dramatically reduced the vehicle's thermal and radar signature. All of these additions provided incredible protection, but they fundamentally altered the physics of the vehicle. The weight of the CV90 skyrocketed. From its original 23 tons, the newer Mark III and Mark IV variants ballooned to 35 and eventually 38 tons. This massive weight increase placed an agonizing strain on the original engine and suspension. To compensate, BAE Systems had to constantly upgrade the power pack. The old 500 horsepower Scania V8 was ripped out and replaced with modern Scania Di16 V8 engines, heavily turbocharged to produce upwards of 1,000 horsepower. The entire suspension system had to be redesigned. The standard torsion bars were augmented with active damping systems, essentially a computer-controlled shock absorber network that measured the terrain and adjusted the suspension tension in milliseconds. This kept the heavily armored hull stable while firing on the move, but it also introduced a vast network of electronic sensors and hydraulics that required meticulous maintenance. This brings us to a critical moment in the vehicle's history. Has the constant addition of armor, sensors, and weight compromised the original highly mobile design philosophy? Or is this simply the necessary price of surviving a modern battlefield? Let me know in the comments below if you think infantry fighting vehicles have become too heavy to do their jobs effectively, or if protection should always trump mobility. I read every single technical debate you guys start down there. The reality of operating a 38-ton infantry fighting vehicle is far less glamorous than the promotional videos suggest. Inside the passenger compartment at the rear of the vehicle, the environment is harsh, loud, and violently uncomfortable. The original Swedish design carried 8 fully equipped infantry dismounts. They sat facing each other on basic bucket seats, their knees practically touching in the center aisle. As the vehicle was upgraded and more internal electronic systems were added, that internal volume shrank. Many of the export variants had to reduce the troop capacity to 7 or even 6 soldiers just to make room for ammunition and computers. Riding in the back of a CV90 at 40 kilometers per hour across rough terrain is a highly physical ordeal. Because there are no windows in the rear troop compartment, the soldiers have no visual reference to the outside world. They are entirely dependent on a single digital screen that displays a feed from the vehicle's external cameras. When the driver hits a ditch, the sudden vertical acceleration throws the dismounts violently upward. When the main gun fires, the concussive shock wave rattles through the thin steel bulkheads, and the distinct acrid smell of burnt cordite quickly filters into the air conditioning system. It is claustrophobic, dark, and intensely stressful. The true test of the CV90's grit did not come in the snows of Sweden, but in the blinding dust of Afghanistan. In 2007, the Norwegian Army deployed their CV90-30 variants into heavy combat in the Faryab province. This was the first time the vehicle was subjected to sustained, high-intensity, asymmetrical warfare. The terrain was a nightmare of sharp rocks, deep wadis, and choking dust that clogged the engine air filters within hours. The maintenance crews worked brutally long shifts in 100-degree heat, replacing worn road wheels and cleaning optical sensors that were blinded by the sand. But when the shooting started, the vehicle proved its worth instantly. During multiple ambushes by Taliban insurgents, the Norwegian CV90s unleashed absolute devastation with their 30mm Bushmaster cannons. The thermal optics cut straight through the dust clouds, allowing the gunners to identify and engage targets hidden in the tree lines at distances where the insurgents could not even see the vehicles. In one heavily documented incident in November of 2007, Norwegian forces were pinned down by heavy machine gun fire. The CV90s rolled forward, absorbed several direct hits from rocket-propelled grenades that barely scratched the ceramic applique armor, and returned fire with high explosive rounds, completely erasing the enemy fighting positions. The infantry inside survived. The troops on the ground were saved. The vehicle had officially earned its combat pedigree. But it was a later modification that truly revolutionized how the crews interacted with the machine. To solve the acoustic noise and heavy vibration issues, BAE Systems began experimenting with continuous rubber band tracks manufactured by the Canadian company SUSE. Replacing the heavy, clanking steel tracks with reinforced synthetic rubber seemed counterintuitive for a heavy combat vehicle. Many armor traditionalists laughed at the idea, assuming a single piece of shrapnel would snap the track and leave the vehicle immobilized. They were wrong. The rubber tracks contained deep layers of reinforced steel cable, making them incredibly resistant to tearing and blast damage. More importantly, the switch to rubber stripped more than 1 entire metric ton of weight off the vehicle. It reduced the vibration inside the hull by nearly 65%. Suddenly, the targeting computers stopped vibrating out of calibration. The crew experienced massively reduced physical fatigue. The vehicle became eerily quiet on paved roads, capable of sneaking up on positions without the deafening metallic screech of traditional steel links grinding against drive sprockets. This constant refinement, swapping steel for rubber, swapping engines for massive power upgrades, digitizing the internal architecture, culminated in the CV90 Mark IV. The Mark IV is practically a different vehicle hiding inside the original 1980s silhouette. It features an entirely digital backbone, allowing it to seamlessly integrate active protection systems like the Israeli Iron Fist. If an incoming anti-tank missile is detected by the vehicle's radar, the Iron Fist system automatically fires a small explosive interceptor, detonating the missile in midair before it ever touches the armor. It is a masterpiece of electronic warfare, but it also means the modern CV90 is entirely reliant on software. If the internal network goes down, the crew loses access to the thermal sights, the laser warning receivers, and the active protection suite. The vehicle reverts back to a heavy steel box. The ultimate unyielding test of this vehicle is happening right now in the sprawling, artillery-scarred trench networks of Ukraine. When Sweden donated a fleet of their older CV9040 variants to the Ukrainian armed forces, military analysts held their breath. These were the original vehicles, armed with the quirky, manually loaded Bofors guns, thrown into the most violent, high-intensity conventional war since the 1940s. The Ukrainian mud, thick and viscous, challenged the vehicle's mobility in ways the Swedish snow never did. But the wide tracks and low ground pressure worked exactly as designed. While heavy Western main battle tanks struggled in the deep mud, the CV90s continued to maneuver, using their thermal sights to hunt Russian armor at night. The 40mm Bofors gun, despite its logistical flaws and exhausting manual loading process, proved absolutely terrifying in trench warfare. Ukrainian gunners utilized the programmable 3P ammunition to detonate rounds precisely over Russian entrenchments, ending firefights before the enemy could even acquire the vehicle in their sights. Crucially, the vehicle's survivability has been put to the ultimate test. There are documented instances of Ukrainian CV90s taking direct hits from Russian artillery shrapnel, kamikaze drones, and anti-tank mines. While vehicles have been disabled and lost, the recurring theme from the front lines is that the armor holds. The crew compartment remains intact. The engine block absorbs the frontal blasts, the heavy spall liners catch the internal fragmentation, and the soldiers walk away to fight another day. This, ultimately, is the true legacy of the CV90. It is not a flawless machine. The original Bofors gun is an ergonomic nightmare that treats the commander like a mechanized coal shoveler. The constant addition of heavy armor has pushed the chassis to the absolute physical limits of its suspension geometry. The passenger compartment is cramped, loud, and entirely unforgiving to the infantry trapped in the back. But it survives. It does exactly what it was engineered to do 30 years ago in the frozen forests of Sweden. It finds the enemy first, hits them with overwhelming kinetic force, and keeps its crew alive when the return fire inevitably comes. It is a raw, brutal machine built for a raw, brutal environment. Thank you for diving deep into the engineering reality of this Swedish heavy hitter with me. If you learned something new about the CV90 today, make sure you hit that like button, subscribe to the channel, and let me know in the comments which armored vehicle we should tear apart next. I will see you in the next one.